Okay, good morning to all. So, the subject operating system, as you know very well. Now, today we are going to start the second unit, that is process description and the control. Right. The contents in the unit, second unit, we have to discuss. These are the process. The first, we have to see the concept of the process state diagram, the process control block, and all the basic concept which are related to the process. The next point we have to see in this particular unit is threads. That is process and thread difference, the concept of multi-threading. So different type of multi-threading model, then the type of threads that we have to see. And the last topic in this particular unit number 2 is related to scheduling, the very important topic, the types of scheduling. Scheduling in the sense it is nothing but the CPU scheduling, and here we have to discuss the different scheduling algorithms and thread scheduling also. So first FCFS is there, that is first come first serve, SJF, shortage job first, then priority scheduling and round robin scheduling are the four CPU scheduling algorithms are there that we have to see it carefully. Right. So from the academic point of view, from the theory, this second unit is very much important because definitely there will be the question on the particular process diagram, the process control block, the what done by schedulers, long-term scheduler as well as the short-term scheduler, and also there will be one numerical for 8 marks or for 10 marks based on this particular scheduling topic. CPU scheduling means you have to solve one numerical. It is very simple, but the logic must be clear to all of you, right? So we will start the process management. The first point is nothing but the process concept. Under the process concept, what we have to see? So we have to see the process, the definition of the process state, the process control block. Process scheduling, nothing but the scheduling queues. What do you mean by scheduling queues? The different types of schedulers, that is long-term scheduler as well as the short-term schedulers, the context switch. The next is nothing but the operation on the process, that is create process and the terminate the process. Then cooperating process, producer consumer problem, inter-process communication, or in simple word we can see it as the IPC. So in that case, message passing system, sync process synchronization, that is direct communication as well as the indirect communication, buffering and message format, and finally the threads we have to see. So to start with the concept of the process, so see here, already we have discussed in the first unit that the program is nothing but the passive entity, whereas that of the process is nothing but the active entity. So your program is nothing but the set of instructions. Suppose I have written program of addition of two numbers, for example. So take a variable a and b, and now I am going to display the result that is equal to c. So this a dot c is nothing but, or addition dot c is nothing but my C program, and it is nothing but the set of instructions. You have put a instruction that is printf, scanf, main, etc., etc. This is nothing. It is nothing but a static entity. But when you compile the programs, means after compilation, you are removing the syntax error from that program, and then you are executing the program. When you are executing the program, that program is get converted into a.exe file. Right? Everybody know this thing, na? So a.exe file is created, and when you execute that a.exe file, or when you execute the program, so that one can say that it is nothing but a process. Getting my word? It is nothing but program in execution. Simple definition of the process. Process is nothing but program in execution, or it is the active entity, or it is a dynamic entity. We can say that. That is the first point. Now the second important point, see carefully, all of you listen it carefully. While the process requires the resources at the time of execution, so when one can say that when my program of addition is running, so it requires resources. Means it requires, what is the resources? Already we have discussed. There are hardware as well as there are software resources. Hardware resources means what? The CPU it requires. They require processor for. They require certain files. They require certain information or data, and they require input and output from the user or to the user. So these are the different type of resources, right? So for my addition of two numbers, the input is nothing but suppose the process so this is one input. enter the number 2, this is another input. So this is one resource. The program or the process is asking user to input certain value. It is nothing but one resource. This particular process is in a running state, that is in the CPU, means the processor or the CPU executes that process, meaning in the sense that the process is currently in a running state and the CPU is one of the important resource. Without CPU resource, the process cannot run. The first important point. And the second important point is that without main memory, so where there must be some space. It cannot run in air or as it is. So where to run that particular process, where to run that particular program, so that is nothing but the space provided by the main memory. So if we want to execute the process, if you want to execute any process, that process must be bring into the main memory for its execution. So CPU and the main memory are the two important resources for the execution of any process. That is the first point. Second point is that it requires certain information. It requires certain data. Say for example, they require certain database file. They require certain input to be taken from the user. And after processing all this thing, the process displays certain output. Getting this point or not? After processing all this thing, after doing all this thing, they provide certain output. Output may be in the form of on the form of screen. It may be on the form of or anything. Right. So these are one can call it as resources. The next point is that these resources are allocated to the process at the time of process or at the time of process execution. Means when the operating system creates a particular process. Now it is again important question. You may ask that where who create the process, how the process is created. So it is the duty of the operating system, or it is the main function of operating system to create the process. Right? And when the process is created, means when the process is getting birth, at the time of its birth only the operating system allocate the resources. Or it may happen that the process is created and it is placed inside the main memory, and at the time of execution, when the process is actually taken for the execution, then and then only the resources are being allocated to that particular process. So two possibilities are there. That is, when the process is created at the time of creation or at the time of execution, the resources are allocated, and these are the resources. So process is defined. It is nothing but the unit of work of operating system. Process can be also defined as it is nothing but the unit of work of an operating system. And there are two types of process. Already we have discussed. There are system processes and there are the user processes. The user processes, for example, suppose I am showing this PPT presentation. So this is one process, right? So we all are logging with the help of particular Google Meet or Zoom software. This is another process which is handled by the operating system, or the user processes. System processes, the processes which are required to run your operating system, whether your Unix is there or whether your Linux is there or whether your Windows is there. So each and every operating system has n number of processes, and in your operating system there are n number of processes available. Right. So process means how we can visualize the process. So you may have your question in your mind that, so how to visualize the process? Is it can be visible to your eyes? So it is a logical concept. Actually, it is a logical concept, and you can view the process with the help of this activity of that particular process, the process control block, and the data section. Right. So this is the basic concept of the process. It is nothing but the active entity, and the program is your static entity. The second important point is that process state. Now, the process state is nothing but the current activity of the process. Current activity of the process. And there are new, ready, running, waiting, and termination. The 1, 2, 3, 4, 5. 5 process states are defined. Remember this point, it is very important. The process may be in one of the 5 states. It may be one of the 5 states. Means when you talk about a new state, that particular process may be in a ready state, or it may be in a running state, or it may be in a waiting state, or that may be in a terminated state. Getting my point or not? So yes, so it is very, so when a human get birth, so we can say that it is first, it is he or she is in a childhood. Then after childhood, he get transformed into young age. Then after young age, she get transformed into the old age. So the same way, the process, when the new process is created or the process is getting generated or created, so one can say it is a new state of the process. Right. Now the ready state. So we will see, we will see the significance of each and every state. So new state, the process is being created. That is newly created process. We called it as a new state. Or a running state, in the sense, this is the running state, means the process is currently in a running state, or the instructions are currently being in a execution, waiting to assign the processor. Means one can say that there are the processes, they are ready to go for their execution. Yes, they are ready. They are newly created process, now bring into the ready state. Ready state meaning is that they are ready to processor. As soon as they get the CPU, the process enters into the running state, right? Now the waiting state. Waiting state in the sense that when process, see here carefully, when process is in a running state, for example, and it requires certain data or it requires certain input from the user, then it enters into the waiting state. So we can say that it is the waiting state of the process. And finally, as soon as the process completely executes, it enters into the terminated state, or it is the process is completely terminated. Getting my point or not? So the significance of each and every process. So we'll see again. So when the process is created, so newly created process is placed in the new state. So we can say that the process is newly are admitted into queue. So here a ready queue is maintained. See carefully, the queue is maintained here, and it is called as the processes are maintained here, and the process is placed inside the ready queue. So meaning is that these processes which are at the ready queue, they are ready for the execution, they are ready for the for their execution. Now the scheduler dispatch, here scheduler dispatch, or it is also called as the CPU scheduling. So see here, see this arrow, particular scheduler dispatch arrow is nothing but the CPU scheduler. And the CPU scheduler, it is the duty of the CPU scheduler to select the process from the ready queue and assign the processor for their execution or for their running. So running state means use CPU. Getting this point? So CPU means what? The CPU takes one process from the ready queue, execute that process, and after complete execution of the process is placed inside the terminated state. The process will be removed from the system. Understood this point or not? The new process is created and it is placed inside the ready queue. It is a queue of the process that are ready to go for their execution. Now the CPU scheduler dispatch, or the CPU scheduler. So here is your CPU. Running state is nothing but here is your CPU, and this particular thing means this particular CPU is being assigned by the CPU scheduler to each and every process. So process is taken from the queue and it is given to the running state. Now process is completely executed, say for example 100% executed and enters into the terminated state, means the task assigned to that particular process is completed. The process is no longer required in the system and it will be removed from the system and it will be terminated. We can say the process get terminated and it will be exit from the system. All right. Second condition. So assume that the process is currently in a running state. For example, again, we'll take the same example, the addition of two numbers. The process is in a running state. But at the time of execution, it requires certain data is to be taken from the user. So it asks, enter the number 1 to the user. And until and unless the user enters the number 1, the process cannot proceed further. Getting my point or not? Until and unless the user enters particular number 1 and number 2, the process will not proceed further. The next execution. So one can say that the process is executed up to 50%, but at 50%, it requires certain input output from the user. It requires certain IO. IO in the sense input is to be required here, or it have to display some output to the user. So till that particular time, see carefully, the process is not placed inside the CPU. It will be removed from the CPU and it is placed inside the waiting state. Getting my point or not? The process is not placed inside the CPU. Instead of that, it will be removed from the processor and it is placed inside the waiting state. So there are different IO queues. See carefully, there are different IO queues or there are different waiting queues. For example, the process requires certain data to be printed, but the printer is busy in printing earlier job. So the process could not get a printer here for its output. So process has to wait. So why to unnecessarily wait the process here? So instead of waiting here, the process is thrown here, that is in a waiting state, and the process waits there for to get its IO operation complete. So see here, as soon as input output operation get complete or event get complete, the process is again placed back inside the ready queue, and it is ready for the execution. Means, say for example, initially suppose 50% execution is completed for that particular process. After 50%, it requires certain IO operation or an event has occurred. The process is placed at the waiting state, and after getting its required IO after completion of event, then again it placed inside the ready state. And here again it is assigned to the processor for its remaining execution. I mean, initially it has executed, for example, 50%. Now remaining 50% will be terminated after 100% execution of the process. Getting this point? It may happen that, say for example, process may run here 70%, but as soon as 70% process executed, some event occur. Some event occur. So until and unless that event get completed, the process cannot proceed further in execution. So it needs to be placed inside the waiting queue. So it has to wait in some waiting queue, in device queue, that is called as IO queue or the device queue. And as soon as this particular event get completed, the process is again placed back in the ready queue. And as soon as it get the chance to get the CPU, as soon as the CPU scheduler select the process from the ready queue, again it will place inside the CPU, and the remaining 30%, because initially 70% is executed, the remaining 30% part of the process executed. So we can say here 100% execution is done, then it will be placed inside the terminated state, or it will be in an exit state. So I think the point is clear to all of you, right? So each process may be in one of the given 5 states. So during the lifetime, so just like a human lifetime, the process is having its own lifetime. So we can say the process either in a new state, it may be in a running state, it may be in a waiting state, or it may be in a terminated state. So this process state diagram, it is same for all. Same for all in the sense, it is for the system process as well as the user process. So it may be your user process or it may be your system process. The process has to follow this path only, or has to follow this diagram, or has to follow these states only, right? So if the process wants execution, it has to be in the ready queue, and after getting its chance, because there is not a single process. We can say there in a ready queue, it is 100 number of processes, they are waiting to get their chance for their execution. Getting this point or not? There are 100 number of processes in a ready queue, and after getting the chance, out of 100 number of processes, one process is selected by the CPU scheduler. See carefully, yeah, one process is selected out of 100 processes, and it is assigned CPU for the execution. So out of this 100 process, also out of this process is taken for the execution, the process is executed completely, and now as soon as completely execution take place, it will be removed. But at the time of execution, when, so see this thing, it entire process or entire flow is nothing but the dynamic. So at the time of execution, it may require certain input output, or it may happen some event occur here. So again, process, as soon as event completed or input output complete, then again it place inside the ready queue. So this is the entire life cycle, and this is the way. So how the process execute in the system, right? So this new to terminate, this is the total lifetime, or it is the life of that particular process. So as soon as the life of the process expire, meaning is that as soon as the process is no longer required, so what is its task? The task assigned to that particular is completed, then and then only the process will be terminated from the system. So I think this concept is now clear to all of you, right? So we'll proceed to the next concept. Process control block. So it is nothing but a data structure, or it is nothing but the one can say that the process is represented with the help of data structure. So data structure, you know very well. Linked list is one type of data structure, single linked list, double linked list, or tree is another one. It is one can say it is a non-linear data structure, or array is your linear data structure. So data structure represents your data. So what is the basic use of data structure? I mean, you can have number 1 to 10. So this number 1 to 10, you can in a linear fashion, means 1, 2, 3 in an array fashion, or 1, 2, 3, 4, 5 it is in a queue fashion, all right? Or you can have in a tree fashion. The same numbers, same data, 1, 2, 3, 4, you can organize in a tree way, in a tree fashion or in a graph fashion. So the representation of the data in the form of data structure, the same way the process control block represents the process. So see the contents of the process control block. See, this is the process control block, and it contains the pointer to the next process. Just it is very similar to your linked list. Just like your linked list, the linked list points to the next link. So say here pointer points to the next process, right? Process state. So already we have seen there are 5 different states, whether the process is in a, it may be in a running state, new state, wait state, ready state, or exit state. The process state for each process. So this is, say for example, process number 1 is here, then process number 2, process number 3, process number 4. So there are n number of processes. There are hundred and thousands of number of processes, and they are pointing with each other, and they are having in a different state. Process state, they are having in a different state, either in a new, ready, running, wait, etc. Right? The program counter indicates the next instruction to be executed in that particular process. So say for example, the program, enter the number 1, enter the number 2, scan a percentage, scan the number 1, scan a percentage, scan the number 2. So this is nothing but the next pointer to the next instruction. You might be aware of the program counter, right? So then the next point is the CPU register. So general purpose register or stack pointer, as well as the index register and accumulators. Then memory allocation. So value of the base and limit register. You might have studied in the CO, computer organization. So each instruction, if you want to load that instruction, if you want to execute that instruction must be loaded inside the main memory. So in the main memory, instruction must have the base address as well as the limit address, right? And deallocation of the memory when the process terminates. So this indicates the which part of the memory is being allocated to that particular process. So entire one can say, and the accounting information as well as the IO stated information. So list of the IO devices allocated to the process. So for example, keyboard is allocated or pointer is allocated. So output device is allocated to the process. So entire one can say Kundali of that particular process is nothing but the process control block. Each and everything. So you find here process number. So the process number is nothing but the unique identification given by the operating system to that particular process. PID, just like a roll number of 1, roll number 2, roll number 3 of the student. So each process is having its own unique process number, and it is called as the PID. Remember this term, PID is called as the process identification or the process number. So see carefully, there may be question for 2 or 3 marks to define the process control block. So you have to explain each and everything. Clear to you? So we'll go to the next point. The very important one, process scheduling. Now there is one question is that what do you mean by scheduling of the process? The scheduling means what? For example, and why there is a need of scheduling? Second question, what is the first question? Why? What is the scheduling? And second question, why there is a need of scheduling? Forget about this technical part for timing. So in simple word, we can say that suppose you are in a third year class, TIT class, right? So you have proper schedule or you have proper timetable of all your lectures as well as practice, right? So your first lecture of operating system, second lecture of DBMS, third lecture of say for example SCI, and then talks, and then say for example other subjects. So proper scheduling is maintained, right? So without this proper scheduling, one can say that each subject is allocated 40 minutes or 1 hour for delivery. So if we assume that there is no scheduling, if there is no timetable, daily timetable for each and every subject, then there is a confusion in the mind of student as well as in the mind of subject teacher. So there is no use at all, right? So scheduling in the sense there must be proper schedule, there must be proper timetable, or there must be proper, one can say that the action plan, defined action plan. Yes, for TIT, so this is the schedule for Monday, this is the schedule for Tuesday, this particular schedule is for Wednesday. So entire week, so that each and every student or each class, whether it is a second year class, whether it is a third year class, whether it is a final year class, they must get benefit. They must get the benefit of attending each and every lecture. Getting this point? Then what is the need of this? So scheduling is nothing but to prepare a timetable or to prepare a schedule of that particular resources. Now the next question, why there is a need of the scheduling? The answer is that the scheduling is required to have the resources, to access the resources. Of course, we are now using the online mode, but if it is in an offline mode, if you assume that you are sitting in a classroom, so we have the 2 classroom. for ACT and BIT, 3 classes. So how to assign the 2 classroom to 3 classes, or we have the 4 laboratories for there are 10 number of batches. For example, AC 3 batches, T 3 batches, and B 4 batches, for example. So how these 10 batches can be accommodated in 4 computer labs. So if you have proper timetable set, for example, 10 to 12 slot is assigned to a second year IT. Then next 2 hours will be assigned to third year IT, and the next 2 hours are assigned to final year IT. So if this proper timetable is set, if the proper scheduling is done, then and then only that each class must get access to the resource. So whether it is a classroom resource, whether it is a laboratory resource, whether it is a faculty resource. Of course, faculty is also one kind of resource. So if you are attending the lecture of operating system, means you are utilizing this resource, faculty of the operating system. You are attending the lecture of DBMS, means you have the access to the resource of DBMS faculty, right? So until and unless you do have the proper scheduling, you cannot have the access to the resource. Getting this point or not? Meaning is that why the scheduling is important? Scheduling is important because neither of the class, there are 2 perspectives. The first perspective is that neither of the class remains as it is without getting the resource. See carefully what I am saying, that neither of the class, means whether it is a second year, whether it is a third year or final year, all classes must get their resources properly, right? So that there is a proper resource utilization. And second point is that, and the second important perspective is that all these resources must get used by each and every class. All these resources must get used by each and every class. There is 100% resource utilization. Means one can say that if you see the timetable of the classroom, if the timetable of the classroom, so for example TIT classroom, so that particular classroom is utilized by second year as well as the final year. Or if you see the lab, for example operating system laboratories, so there are 20 computers. That particular lab is initially or in the morning time used by the second year people, in the afternoon time it is used by the third year student, and in the evening time it is used by the final year student. Of course it is in an offline mode, right? Meaning is that all these computers are utilized 100%, means starting from the 10 o'clock to evening 5 o'clock, the lab is busy. The first point means you are utilizing your resources completely. And the second point is that neither of the class, means neither ACT or B student, they remains as it is without getting their resource. Means each and every student get the computer for its practical purpose, right? So 2 perspectives we are obtaining here by proper timetable, by setting the proper timetable, or by setting proper schedule of all the classes. Getting this point or not? So meaning is that we are utilizing the resources 100% and ensuring that neither of the class remains as it is. Now again come to our operating system concept. So in operating system, the scheduling is defined as it is the mechanism that handles removal of running processes from the CPU and selection of the processes based on certain strategies. What is the definition of scheduling? Mechanism that handles removal of running processes from the CPU and selection of the processes from ready queue based on particular strategy. So meaning is that CPU is one resource, just like your classroom or just like your laboratory, right? And processes, these are nothing but these are similar to your students, or these are similar to your ACDB classes. So we have to obtain here, or we have to fulfill the 2 criteria or 2 perspectives. One is that we have to ensure that CPU must not sit idle. There must be 100% CPU utilization. Means the CPU, there must be at least one process in the CPU for its, and the processor must execute the process, right? Means processor must be busy all the time. The first perspective. And the second perspective is that all programs must get the CPU for their execution. Neither of the process or neither of the programs remain as it is without getting the processor. See carefully, yeah? 2 perspectives. The processor must be busy all time to execute certain process, and the same time all processes, though there are n number of processes, though there are 1,000 or 10,000 or n number of processes, each and every process should get the CPU for its execution. And how this thing is possible then? How we can get? So this is with operating system achieve this particular target, so operating system has a proper scheduling mechanism. So this scheduling mechanism or the process scheduling tells you that when process is placed inside the CPU and when the process is executing in that particular processor or the CPU, so as soon as the process executes completely, the process is removed from the processor and enters and put it inside the terminated state, and immediately the processor is being assigned to the next process, or immediately the next process is taken by the CPU for the execution. So who will assign the process? The CPU scheduler will assign the process to the CPU for the execution. And from where the process is taken, you know that it is taken from the ready queue. So from ready queue, CPU scheduler select the process and place inside the CPU for its execution. As soon as the process executes completely, it will given into the terminated state, or the process will be removed from the system. Now, if the process wants certain data, if the process wants certain information from any input output queues, then process must be removed from the processor. See carefully, the process must not be kept in the CPU, must not kept in the processor if the process wants certain data to be taken, or to be taken from the certain input devices. So that must be brought inside the waiting queue of that particular device, and immediately the CPU is assigned next process for the execution. So what is the meaning is that? So this is actually the multiprocessor architecture. Multiple processes are being executed. Meaning is that, or we can say it is a multi-programming architecture. Multi-programming in the sense, yes, one process currently is taken by the processor, but so after 50%, the process wants certain input output. The process is removed from the processor, removed from the CPU, and placed inside the waiting queue. At the same time, immediately the next process is taken by the CPU for its execution. Right? So there is a second process executed by the CPU, and the first process which is in a waiting state, and there are 3, 4, 5th number process, they are in a ready queue. Right? Or it may happen that there is one process completely terminated, 100% executed, so it is placed inside the termination state. The next process is taken, it requires certain operation, input output, enters into the waiting state. Immediately the next process is taken, and that process is currently in a running state, and there are some processes they are waiting in a ready. Now just visualize in front of your eyes. Yes, this is the process state diagram. So some processes they are in a waiting state, some process is in a running state, some process is in a waiting state, and some process they are completely terminated or they are executed successfully. So this is possible with the help of your scheduling. Meaning is that each and every process is performing its job, as well as the processor or the CPU is also performing its job correctly. Now come to the next point, that is called as the scheduling queues. Now we are now entering into the queue that is nothing but the waiting queue, and it is called as the scheduling. So there are the two different types of queue. Already we have seen at the time of process state diagram. One queue is maintained at the IO device queue, and another queue is maintained at the ready queue. The processes that are ready, they are placed inside the ready queue, and the processes they are waiting to get certain device, they are placed inside the device queue. So scheduling queues are the when process enter into the system, they are put into the job queue. It is called as the ready queue. So processor is, and it is queue is nothing but this is your PCB. See here in the figure, you can see that this is the PCB. This is the PCB of one. PCB7 means this is the process control block of the 7th process. PCB2 is nothing but the process control block of the 2nd process, and each process is pointing to each other with the help of the pointer, right? So this is first one, that is nothing but the ready queue at the ready state of the process state diagram, and device queue is at the one can say at the waiting state of the process state diagram. So it is nothing but the list of the processes waiting for particular IO device. It maintains the list of the processes waiting for particular IO device. So if you take very simple example, printer. So printer is having queue, meaning is that suppose one process is in a printing state and another process comes there. So another process has to wait. So printer maintains the queue of the process, right? Or for another example, say for example, say input device, say for example keyboard. Suppose a process wants data to be taken from the keyboard, but the first process or the earlier process is taking is busy in doing the keyboard work. So we can say that the two processes are in a queue and they require input from the keyboard, for example. So this is nothing but the device queue, the list of the processes waiting for a particular IO device. Each device has its own device queue. So each and every input device output device, they maintain the device queue. So if the process wants that wants the work to be performed by the device, it enters into that particular device. So processes allocated to the CPU execute for a while and eventually quits or interrupted or wait for event, that is IO request complete. This request is shared with the device queue, or it is requested to the shared device or the disk. Since there are many processes in the system, the disk may be busy with IO request and other. So the example is given same way, just like your printer or disk is another example of input output device. So the process therefore may have to wait for that to getting that particular disk. Next is nothing but see here IO device queue. So process control block for 3, PCB for 4, process control block for 14 number process, PCB for process number 6. So these are nothing but the IO device queue. Now the representation of the process scheduling is by the queuing diagram. So see here, this figure represents the queuing diagram. See, it is written here QUEUEING, queuing diagram. So this diagram is very similar to your process state diagram. This particular diagram is very similar to the process state diagram. We have the new state, ready state, running state, waiting state, and the terminated state. The same process state diagram, it is now represented with the help of device queue and the ready queue. So one can say this is nothing but the queuing representation of the process state diagram. See carefully, yeah? This is the representation of the process state diagram with the help of different device queue. So here the rectangle box, whatever may be the rectangle box here, whether it is a ready queue or IO queue, they represent the queue, that is ready queue or the device queue. Means queue in this particular box are represented by the rectangle box, and the circle represents the circle represent the resources, right? And arrow represent the flow between the process. So when this ready queue is nothing but your ready state. Ready queue is nothing but your ready state. When the process is placed, when the process is entered into the system, it is first placed inside the ready queue. So ready queue may have n number of processes, 10, 50, 100, 10,000, 1,000, 10,000 number of processes are placed inside the ready queue. CPU scheduler select the process from the ready queue and it is assigned to the CPU for the execution. It assign the process to the CPU for its execution. Now when the process is completely executed, see carefully, when the process is completely executed, it is removed from the CPU and it is terminated. The process is now terminated state. The first case. Second case, now assume that the process is in a running state. Running state means process is executed by the CPU and number 1, some IO request comes there, means it requires certain IO input is to be taken or output is to be displayed by the process. Then it is placed inside the IO queue, right? Means the process is now removed from the CPU and it is placed here in the IO queue, right? And at the same time, immediately the next process is taken from the ready queue and it is given CPU for its execution, right? So first process which is in the IO queue, has the IO request and it is given to the IO queue. And as IO means it is a resource, whether it is your printer resource or keyboard or any disk resource, any type of IO resource is there. And as soon as these processes assign the IO, as soon as the IO operation complete, again it is put back inside the ready queue. Suppose process, again it requires 4K child, means it is possible that the parent process, see carefully, parent process may create the child process. Suppose there is one parent process, it may create 2, 3, n number of child process. The child process is nothing but it is similar to the process, but it is just called as the child process because it is created by the process itself. And why the process create the child process? Because certain task is very big. So instead of handling that particular task by a single process, the process can divide its work into multiple number of tasks. Say for example, 1, 2, 3, 4 children processes are being created, and the same task is now divided into the multiple child process, and all the child process execute in the same manner as that of the original process. So 4K child. So in Unix there is a fork command. There is a command called as a fork to create a new process. Then child process executes similar to the child process, means it is very similar to the process itself. The child process terminate as soon as the work or the task assigned to that child is completed. The child get terminated, and the original process is again placed inside the ready or the parent process. Original in the sense it is called as the parent process. Now suppose third number, an interrupt is occurred. Suppose a particular process is in a running state. Again, and interrupted it. Suppose a class is going on and some student is want to enter into the class by sending the request, so the class get interrupted or the class get disturbed. So waiting for interrupt, and as soon as the interrupt complete, again that process is placed inside the ready queue. And after in the ready queue, the CPU should select the process and assign to the CPU. So this is nothing but the same way as that of your process state diagram, but only the thing is that these are the different device queue, IO request queue, or the child is created or wait for. Now the what is meaning of time slice? Time slice is the way that, suppose say for example 5 milliseconds is assigned to the process. Suppose P10 number is process and it is placed inside the CPU, and the only 10 milliseconds of the CPU time is given to that particular process, but process may require 20 milliseconds, means it cannot complete it within the assigned predefined time slice. As soon as the time slice expires, immediately the process is removed from the CPU and put back inside the ready queue. So next slot, when the next turn comes for that process, so remaining 10 milliseconds will be executed and the process will be terminated. So getting all of you? So this is called as the queuing diagram or the queue diagram representation of the process. The queue diagram in the sense there is nothing but the different device queue and different resources, and their flow is represented with the help of this arrow. Clear? So we'll go to the next point. Now the scheduler, very important. So there are 2 or 3 different types of schedulers here. So we have seen that in the process control block, the process is being selected from the ready queue and it is assigned to the processor for the execution. There is one scheduler and it is called as the CPU scheduler, or it is also called as the short-term scheduler, right? So basically now see, scheduler means what? There are the 2 or the 3 different types of scheduler, that is called as the long-term scheduler, the short-term scheduler, and the mid-term scheduler. So what is the meaning of scheduler? What is their purpose? That we'll see in detail. So first we see carefully the long-term scheduler. So it is also called as the job scheduler or long-term scheduler, and it is executed in between the 2 state of the process state diagram, that is the new state and the ready state. So see here, from new state, new is the, say for example, operating system creates n number of processes at the time. So out of this n number, suppose 100 processes are being created. So out of this 100 processes, 10 processes are being selected by the long-term scheduler and it is placed inside the ready queue. Getting my point or not? So operating system creates, for example, 100 processes. So out of these 100 processes, only 10% or the 10 processes are being taken by the long-term scheduler and it is placed inside the ready. So one can say that there are the 10 processes. So here 100 new processes are being created, but out of 100, 10 are here, and here are only 90 processes. 90 processes are here, and 10 processes are in the ready. Ready queue means the next state is nothing but the running state, right? So it determines which programs are to be admitted to the system for processing. It is the duty of the long-term scheduler, right? So it select the processes from the queue and load it into the memory for the execution. So this ready queue, in a simple word, you always remember that ready queue is nothing but your main memory. Ready queue is nothing but your main memory. So the process is loaded inside the main memory and it is now waiting for the processor or the CPU for its execution, right? So the first function of the long-term scheduler, so see carefully, there are the 2 different functions performed by the long-term scheduler. First important function is nothing but the control the degree of multiprogramming, and second important function is nothing but the to provide the balance mix of the job. These are the 2 important functions that are carried by the long-term scheduler, right? So control the degree of multiprogramming, this is the first function performed by the long-term scheduler. Now what is the meaning of degree of multiprogramming? So degree of multiprogramming defined as average rate of process creation divided by average rate of process departure, that is equal to 1. It is called as the degree of multiprogramming. It is called as the degree of multiprogramming. Very simple way. Now see here one example. I'll just explain you one example. For example, in first year engineering or first year IT, say for example 60 students are taking admission to the first year, right? And at the final year IT, the same 60 students getting their graduation. They completed their graduation. So one can say that what is the meaning of this? 60 students, they took the admission in the first year, and the same 60 student, they passed out from the IT during the 4-year course. Getting this point? So meaning is that average rate clear. So meaning is that input is equal to output. One can say that very simple word. So when I can say that this is my ratio, input ratio is equal to output ratio. Clear. So degree of multi-programming is nothing but number of processes maintained in the system. How to maintain? So how to control the degree of multi-programming? Now take example, 60 students admitted in the first year, 60 students pass out from the B, right? So 60 divided by 60, that is equal to 1, input is equal to output, right? For again another case, take the case number 2, 60 students admitted in the first year, 60 students admitted in the first year, only 50 students pass out in the B, right? So what about remaining 10 students? So meaning is that the remaining 10 students, they must be either in second year, third year, or in the drop of final year. Getting my point or not? So initially 60 students are admitted in the first year, but at the final year, but what is the result? I get here only 50 students, not the 60 students. So there is a question about the 10 students. So 10 students are in a system, somewhere are in a system. Getting my point or not? They may be in a drop year, they may be at third year, or even they may be at in second year due to their M3. Getting this one. So meaning is that output to input ratio is not equal to 1 in this case. Input to output ratio is not 1 in this case, right? Take another example. 60 students admitted in the first year, 60 students admitted in the first year, and only 30 students pass out in the final year. So meaning is that we have 60 divided by 30, that is nothing but your 50%. So the output is only we get here 50%. Remaining, where is the 50% student, right? So these 50% student, they are somewhere in the system. Meaning is that the system is not proper working here. Clear or not? The functioning of the system is not proper here because the number of students which is getting at the final year, they are very less. They are 50%, and the 50% are in a system itself, right? So when I can say that the system is very perfect, when I get input is equal to output, 100 student or 60 admitted, 60 pass out, the excellent system. The output given by my system is excellent. But 60 admitted and 50 pass out, 10% are failure. But if the 60 admitted and only 30 pass out, 50% is the failure of the system. Meaning is that system or the student. Meaning is that this degree of multi-programming, again come to our concept of operating system. This degree of multi-programming, suppose 100 processes are initially created. So out of 100 processes are inputted to the system, and same 100 number of processes are at the output end. We can say that yes, my operating system is performing correct job, or it performing optimum job. Means 100 divided by 100, that is equal to 1. Getting this point? Second case, 100 process enters into the system, they are placed in the ready queue. But at the output end, I get only 50 process completely executed. So where is the remaining 50% process, or where is the remaining 50 process? So they are somewhere in the waiting queue. Getting my point or not? The 50% process are only successfully terminated, but the remaining 50% process, they are not able to complete their task, or they are not able to successfully execute it. Meaning is that they are somewhere in the device queue, different. They are waiting to get certain devices, and due to they could not get the devices, they could not complete their execution. So the output or the ratio of my system is only 50%. Means I can say that there is a problem, or there is a severe problem in this case. I have to identify, or I have to rectify that particular problem, right? So in the sense, it is the duty of the long-term scheduler. Come to this point. It is the duty of the long-term scheduler to see the degree of multi-programming. Getting this point? So it must not happen that. So again, so the long-term scheduler must put the next. So initially it put 100 process. It select the 100 and place the 100 process. But now it observe that out of 100, only 50 passed out, or only 50 terminated, and 50 remains as it is. So at the next time, it must not select the 100 process, because if it enters the 100 process here, so the total count in the system becomes 150. Getting my point or not? Initially, suppose the long-term scheduler select the 100 process, and your system is not performing well. It is not performing optimum. So only 50% is going out and 50% are still in the system. Meaning is that, so in this the long-term scheduler, it has to see that yes, now the admission to the new, now it come down to be 50% only, or it is to be converted to be 50%, means only 50 processes are to be selected and then admitted to the ready queue, means the total process becomes here 100. So out of this 100, again 50% are executed completely. Why? Because if it does not do so, then it unnecessarily increases the load on your system. So every time it go on adding 100 process in the system, so this count becomes 150, then 250 and 350. By 100 this point, this particular count becomes increase 100 every time, and at the output you are getting only 50% or only 50 processes, not the 50% even. So the system collapse at particular particular point of time. System get collapsed because the number of processes input at the is not output process. So it is the duty of the long-term scheduler to provide the or to control the proper degree of multi-programming. It has to see if the system is performing correct, if the system is performing fine, no question, go on adding the process. But if it sees that yes, it know that now the process is, if the system is not performing correctly, so it has to reduce, it has to low down the number of, it may be 40 or it may be 10 process, only add the new 10 process in the system. So it is the totally depend upon the long-term scheduler. If the long-term scheduler fails, the entire system fails here. The first important task or first important function of the long-term scheduler. The second important function is nothing but to provide the proper or the balanced mix of the job. What is the meaning of balanced mix of the job? So there are the two categories of the job or the process. Job, or you can say processes. So there are some IO bound process or some CPU bound process. So IO bound process in the sense, the processes, there are certain processes, they spend or they require maximum their time on doing their input output operation. And there are some processes, they do not spend their time on the input output, they just require a CPU for their execution, they execute the CPU, executing the CPU and they terminate it. So the processes, they maximum require CPU time, they are called the CPU bound process, and the processes which are required IO operations maximum time, they are called as the IO process or IO bound process. So it is the duty of the long-term scheduler, see carefully, understand, it is the duty of the long-term scheduler to provide proper mixing of the IO bound as well as there must be 50% IO bound process and there must be 50% CPU bound process. So if it is not so, if all the process they are IO bound process, suppose 100 process are taken and all these 100 process they are IO bound process. So what happens? See, the first process is taken, placed in the ready queue, and it is given to the CPU for the execution, and it is IO bound process. Means the process enters into some IO queue in a device queue and to perform its IO operation. Second process is taken and it is again IO bound process. The processor execute the process, but it cannot execute completely, and it is again placed inside some IO queue, some device. Third process same way, fourth process same way. So meaning is that there are 100 processes, they are in a device queue, and there is very less processes for their execution. So it unnecessarily what it increases, or they are the maximum number of process enters into the waiting state. The maximum number of process enters into the waiting state if the all processes are IO bound process. Second case, if all processes are CPU bound process. So what happens if long-term scheduler select all the processes, they are CPU bound process. CPU bound means they require only CPU, they don't require any IO operation, right? So first process is taken, it is a CPU bound process, it executes, CPU executes, terminate. Second process, CPU execute the process, don't require any IO, the process get terminated as to 100% execution. So all the processes, they require CPU only, and they do not enter into the any device queue, they don't require any IO operation. So meaning is that if all the processes are IO bound process, so in that case, all your device queue, all your waiting queue, they becomes empty, and you are unnecessarily increasing the load on the CPU itself. Getting my point or not? You are overloading your CPU by providing all the processes, they are CPU bound process. Getting my point? So if the processes are all processes are IO bound, then also the CPU remains idle in that case, and all the device queue and all waiting queue, they become full. But and if all the processes are CPU bound process, then the burden on the CPU get increased, and all the device queue and the waiting queue remains empty as it is. So it is the duty of the long-term scheduler to have the proper mixing. There is a 50% IO bound process and there is a 50% CPU bound process, so that the CPU will be also busy and device queue also get some work to do, right? And this is the two important concept handle, or this is the two important functions they are carried out by your long-term scheduler. First is nothing but the control the degree of multi-programming, and the second is nothing but your proper mixing of the IO bound as well as the CPU bound process. I think it is clear to all of you, right? If you have doubt, you can ask me, right? The second is nothing but your short-term scheduler. Short-term scheduler, it is in between ready queue and the running queue. And why it is called the short-term scheduler? Because the execution time of the short-term scheduler, as the name itself is very short. Means it executes very fast, or it runs very fastly. And the long-term scheduler means it runs very slowly. The execution time of the long-term scheduler is high as compared to the execution time of the short-term scheduler. So duty of the short-term scheduler is just to select the process from the ready queue and assign to the CPU. And when it sees that there is no process available in the CPU, it immediately select the process from the ready state and assign the CPU for the execution. So select the process ready for the execution and allocate the CPU to one of them. So this is the work of the CPU scheduler is only this, to select the process from ready queue and assign it to the CPU for the. If there are 10 processes in a ready queue, see here, there are 10 processes in a ready queue and they are ready. So how you can select the 10 processes? How you can select the one? There must be a decision making. For example, there are 60 students in TIT class, right? Suppose we want to assign or we want to. So how to assign this? So means one process is to be taken because all are ready. All are ready. So one process is to be taken and it is given to the CPU for the execution. The same way, all are in a third year, right? So out of 60 students, how to assign the CR or LR? So there must be some decision making. We have to apply certain criteria. Means we can have the criteria like the student having the good academic record can be work as a CR, or the student is having good extracurricular or co-curricular activities will be appointed as a CR. Here, the CPU scheduler has to take the decision, and for the decision making, there are some certain strategies, there are certain algorithm it has to follow. That we'll see in the later on topic, right? So this is all about the long-term scheduler and the short-term scheduler. One scheduler, it is also called as the midterm. So the queue are placed inside the ready queue, and the partially executed swap process they are placed inside the disk, secondary storage or the hard disk. So swap in the process in the ready queue and swap out the process from the ready queue. It is called as this particular called as the swapping. Means ready queue. So processes they are ready, they are placed inside the ready queue, and the process which are 50% executed, they are placed inside the disk. This is called as the secondary storage disk, and this particular function is carried out by your midterm scheduler. Right? Means partially executed process they are placed on in the disk or secondary storage, or in simple word they are placed in the hard disk. Right? Partially 100% completed and again completely executed. Right? The next point is nothing but your context switch. Context switch is nothing but the processor or the CPU switches from one process to the next process. That is called as the context switching between the process. Right? Context switching in the sense CPU switches so fastly between the process one. It is taken initially for the execution. It requires IO placed inside the IO queue. Process P2 is taken. Process P2 executed. It requires IO again inside the P2 is again some IO queue. P3 is taken. P3 is completely executed and enters into the terminated state. P4 is taken. So in the process P1, P2, P3, P4, P5, P10, P100, P1000. So CPU switches so fastly between the processes, and that is called as the context switch. Remember this point. Switching between the processes. Switching between the processes is called as the context switch concept. Remember this. Now here is the difference between the long-term scheduler, short-term scheduler, and the mid-term scheduler is enlisted here. The long-term scheduler is called as the job scheduler, whereas the short-term scheduler is called as the CPU scheduler. Very fast. Mid-term scheduler is called as the swapping, or it is also called as the swapper. The speed is between the long-term as well as the short-term scheduler. It controls the degree of multi-programming, long-term scheduler, whereas the less control over the degree of multi-programming for the short. That reduces the degree of multi. Minimal in case of time sharing system. Scheduler also, but mid-term scheduler is present in time sharing system. Then it select the process from job pool, whereas in case of short-term scheduler, it select the process from the ready queue, right? And processes are reintroduced in case of mid-term scheduler. The states of the process state diagram from the long-term scheduler, that you know that it is from new state to the ready state, and for the short-term scheduler, it is from ready state to the running state. The good process mixing is done by your long-term scheduler, whereas the selection of the new process and assign it to the CPU, this work is performed by your CPU scheduler. We have to see the different scheduling algorithm, that is called as the CPU scheduling algorithms. That is nothing but the duty of your short-term scheduler, right? So that's all about the scheduler concept. The next concept is the, basically there are the two main operation, that is the process creation and the process termination. So process creation means process may be created several new process via create process command, or there is a fork system call. So there is one process, it can have the multiple number of process, and these are called as the child process. So two possibilities: parent continue to execute concurrently with its child process, means child process currently in a running state, as well as the parent process currently in a running state, that is also possible. So fork is the system call to create the new process in the system. And the termination, so as soon as or perform its task assigned, the process may be terminated. So the child process terminate when it finishes its task or execution, the OS will delete that process. And as soon as the process is deleted, or as soon as the process is terminated, then whatever may be the resources allocated to that process, that will be removed from that particular process and assigned to the next process. See here, what is the importance of process termination? When you are going to create the process, you have to assign all the resources to the process. But when the process is terminated, the operating system remove whatever may be the file, IO, or different resources assigned to the process. All the resources are now removed from the terminated process. Getting this point? So parent may terminate execution of one of its children process. So operating system terminate the process execution, or parent process may terminate the execution of the child process. So child has exceeded its usage of the some of the resources, or the task assigned to the child as no longer required, or the parent exit and OS doesn't allow to child to continue the process. So these are the reason why the process get terminated, why the parent process terminate the child process, or why the OS terminate the child process. If the process is no longer required, the process is terminated with the help of a different command, right? So there is a command called as exit system call, or there is a command called as abort. With the help of this, you are going to terminate the process. So remember these two operations: process creation and process termination. So for today's course outcome, so we have learned in the today's session the process concept, the process state diagram, the process scheduling, the operation on the process, two types of process scheduler, three types of process schedulers: long-term, short-term, and the mid-term scheduler. Process creation and the process termination of the two important operations. The outcome to understand the process concept and the thread management. The short answer question, very important. The questions asked in the in semester as well as the end semester examination on the topic covered are: draw the process state diagram for 2 marks. 100% this question is there in your in sim exam. So new, running, new, ready, running, waiting, and terminated state. Write a note on process control block. How the degree of multi-programming is maintained by the long-term scheduler. The discussion which we have discussed in the lecture, you have to elaborate all the thing, how the degree of multi-programming is maintained by the long-term scheduler, and finally the differentiate between the short-term and the right. So these are the references. So you can also refer the NPTEL video lecture. The link is given. You can have the tutorials point for the operating system subjects. So thank you. So for the today's lecture, we stop here.